Hi everyone, and welcome to part 6 of this video tutorials. In this video we are going to switch to C++ interface of lib3mf library, and similar to part 2 video we will output the total number of vertices and triangles as well as vertex positions and triangle indices. So let's start off by removing some of the code that we have inside import 3mf class. So we no longer need to include this header file, so I'm just going to simply remove this. And we are also going to change a few things here. So this function now returns a boolean, and I'm also going to switch from a string to white charts. So the reason I'm going to do that is because a lot of C++ functions inside lib3mf uses W string rather than a string. And to avoid switching back and forth between these two, I'm just going to simply use W string. And let me go ahead and change this in our CPP file as well. Okay, and now this function returns a boolean, and we can go ahead and remove all this code inside here. And this function returns true for now. We no longer need this file. Okay, great. Now let's go ahead inside main app.cpp and let's include our import 3mf. Okay, and inside our init function, somewhere here, for now I'm just going to load cube base material 3mf that we have inside our resources. So let's go ahead and add that. Okay, and we now need to convert this to W string. So I'm going to create a new W string object, and I call it path WSTR, and I simply pass in the begin and end to our string. So okay, so for now that's how we convert from a string to W string. And let me go ahead and create our import 3mf object. And passing path WSTR in there. Okay, so that should be good enough for now. And let's go back inside import 3mf, and let's start by including some files. Okay, so inside import 3mf CPP, we are going to include two header files. The first one is called nmr import stream gcc native.h, and the other one is called nmr model reader 3mf native.h. Now that we included these two header files, let's go ahead and add the following codes. Okay, so the first object that we are creating here is called pModel, and pModel class basically is an in-memory representation of a 3mf file. The next object that we are creating is called Modular String, and basically import string class is simply a base interface for importing from different data sources. So when you create this object, you also need to pass in the file name character str, and we pass this to the constructor of this object. The next object is called model reader, and basically the model reader class is what reads the model file and generates an in-memory representation of it. So when you create this object, you need to pass in the model to the constructor. And once we have that, we are ready to actually call read stream of the model read and pass in the model stream to it. So let me go ahead and call this function. So our model reader object has a function called read stream, and this function is taking a model stream object. Let me go ahead and wrap this inside this try block and catch any exception that we get. So if something goes wrong inside this model, if this is a bad file, we want to print out the exception, the NMR exception, and see what the problem is with the file. So I'm gonna call CNMR exception. And let's output the exception error message. So and we simply throw an exception here. All right. So once this is done, let's go ahead and print out the number of objects and build items that we have inside our 3MF file. So I'm simply gonna call these two functions. So as you can see, our model class has these two convenient functions. So if you go inside NMR model.h, you can see that there are some convenience function for objects or base materials. We have some functions for retrieving textures. Function that we are calling is returning the number of objects that we have in our resources element. So let me close this. Let's go ahead inside Visual Studio and compile our code and see if everything is okay. Okay, so we have a compiler issue here. Oh, no, that's my bad, sorry. So I need to change this to, yeah, just change it to capital S. All right. So let's go ahead and inside import 3MF, I'm gonna put a breakpoint somewhere here, or let's just run this. Oh, I've also forgot to. There we go. Okay, so seems like we are throwing an exception here, and let's see what the problem is. It's cube-based materials. Let me see if I type the file correctly. Yes, I think the file name that I was passing was wrong. So it's actually cube base material, not base materials. So let's run this again. Great. So as you can see, we were able to load our 3MF files and print out the number of objects and item counts for that. Let's go inside Sublime and let's open up the 3D model for this file so we can actually see what we are printing. Okay, so as you can see, our 3D model has two objects inside the resources element, and we also have one item inside the build element, and that's what exactly we are printing here. All right. Okay, so let's go ahead now and access build item objects. So let me close this main app.cpp, and in order to do this we need to include another header file. So let me go ahead and include model classes NMR model build item .head. Okay, and right after this we need to add the code to find out the number of items inside our build element. So let me go ahead and put our 3D model in another tab. Let me close this. Okay, so we can see things a little bit better. Alright, so the function that we are going to count is called get build item count. So I'm going to create const unsigned int, and that gives me the number of item counts. Alright, so now that we have this, we can actually have a for loop, and we can call get build item and pass in the current index to that, so we can actually get access to the build item. So we now add the for loop here. Okay. So inside this for loop, we are going to create a new object of p model build item. So p model, and that's the reason why we actually needed this header files. So let me go ahead and type this here. So this function needs to we need to pass index to this function, so I pass I here. Great, so now that we have this, let's go ahead and print out the transform metrics as well as the object ID for this item. So let me just copy and paste this code. Alright, let me also rename this thing here a little bit. Alright, so now we should be able to print out this information that we have in line 42. Oh. I cannot type today. Perfect. So let's go ahead and run this code. Great. So as we can see, we are printing out the transformation metrics as well as the object ID for our item. Okay, so the next thing we want is to access the resource object that this item is referring to by object ID 3. Okay, so in this case, the resource object is a components object which has a component that refers to another resource object, which is in fact a mesh object. So if you look at here, object ID 3 is a components object, and inside that we have a component that refers to object ID 2, and the object ID 2 in fact is a mesh object. Okay, now in this example, there are two ways to access the mesh object that the component item is referring to. The first way is to loop through each component's element and find the object that corresponds to the object ID. This is very similar to what we actually did with the build item. The second way is simply merge all the component objects into one mesh. So in the first way, what we would do is, let's say I have 4 components here, or let's say I have 3 components here, okay, which is totally valid. And basically what we do is we loop through all these, we loop through the components, and we see, okay, we have a component object ID 2, so we create a mesh object. So we are going to create a mesh object, and this mesh object is going to have 8 vertices. Let's type it here, and 12 triangles. Okay, now we go to the next one and we create a new mesh object, and we do the same thing for the third one. So now we have 3 mesh objects, and each one of them has 8 vertices and 12 triangles. In the second way, what we would do is we would actually merge all these 3 components to one mesh object. So we will create one mesh object. So let me get rid of this. And all of these 3 are gonna become one mesh object, which would be 24 vertices and 36 triangles. Okay, hopefully this makes sense. Sorry, let me type this. I can't type today for some reason, sorry. So okay, now again, this is totally up to us to decide whether or not to separate each component or merge them all into one mesh. In this video, I'm gonna show you the second way, which makes things a little bit simpler for sake of this video. Alright, so let me undo my change inside here. Okay, and let's go back inside the import 3mf CPP, and first thing that we need to do is to get the object for the items. So we can do this by simply calling item get object, and this gives us a C model object pointer. Alright, so once we have that, we are gonna merge all the components that are inside these components. So to do this, what we would do is we first create a mesh object, okay, and this is a shared pointer, and once we have that, we call merge to mesh for the C model object, and we pass in the pointer to our mesh. Alright, so by doing so, we now have created a mesh object, and this is the mesh object that we are referring now. Now that we have this mesh object and it's created, we can go ahead and access pretty much everything that is inside here. Alright, so the first thing I'm gonna do is I'm gonna print out the number of vertices and triangles that this mesh object has. Alright, so to do this, you can simply call these 2 functions. Alright, so to get the number of vertices, you call mesh get node count, and for triangles you call get face count. Alright, and I go ahead and print out these values here. Alright, the next thing that we want to do is we want to print out the position of each vertices. To do this, we add this code. Okay, so what we need is we are actually looping through this vertex counts, and we are going to access each mesh vertex by calling this get node and passing the index to that. So basically this would actually give us a pointer to mesh node, and if you go to nmr mesh types.h, you can see that mesh node is a simple structure that gives us the index and position for each of these vertices that you see inside here. Alright, we also have similar thing for our triangles. We can access the triangle index as well as the indices that we see inside triangle. So let me go ahead and add the code for triangles indices as well. And this is pretty much very similar to what we did in part 2 of this part 2 video. So okay, let me just make sure everything's good here. Alright, so let's go ahead inside Visual Studio and run our code and see if everything looks good. Perfect. So as you can see, we now printed out the number of vertex count and face count, as well as the position for each of the vertices, and also the triangle indices that this file has. Alright, so that's all I have for this video, and hope you found it useful. Thanks for watching again, and see you in the next video.